Hello everyone. In today's lecture, we are going to see what Xmpp is. Okay. The full form of Xmpp is Extensible Messaging and Presence Control. Okay. So it is a message-oriented middleware that is based on XML. Okay. So XML is an extensible markup language which is particularly used for unstructured data. So XMPP is useful for real-time exchange and structured data, and it is an open structured protocol. So XMPP uses a client-server architecture. It uses a decentralized model, meaning that there is no server that is involved in the message after, and it provides facilities for discovery of messages which are residing locally or globally across the network, and availability information for these services. So as we can now basically think about it, so it is well suited for cloud computing environments where vertical or virtual machines, networks and firewalls are involved and would otherwise present and the alternate services, discovery and message based solutions. So you know that this was like which helps in XMPP. We can do this very similar like PIN protocol. So in the case of PIN, basically when we have to in environment of firewalls, so PIN cannot be used as such. So in this particular case, in the case of XMPP, it basically removes all these constraints, these barriers, and for having discovery of these services. And if it is discovery services locally, okay, then there is no problem. But if it is across the network and there is no firewall in between, then XMPP can still work. Okay, we'll see the highlights of XMPP: the decentralization, open standards, okay, security and flexibility. So some of these highlights of XMPP protocols, it is based on the concept of decentralization, okay, where it is no central server, and then everybody can run the XMPP server theoretically, can it is based on open standard. So there is no environment of royalistics or gathering permissions into implement the XMPP specifications. So different security features that standard ones such as authentication, encryption, and decryption can be implemented using XMPP to like on the top of XMPP. Rather than XMPP also allows flexibility in terms of supporting interoperability between different systems with the different devices and with different protocols and so on. Okay, so consequently I was giving you that analogy with the traditional pin protocol that is used for internet, and here we are trying to have something similar, but it is a bit different in this particular manner. So it is now if you look at the particular figure, okay, if you can see this particular figure, what we can see that XMPP not only possible to communicate with other servers, like in the case of traditional internet, okay, in the case of traditional internet, okay, but also with other messaging platforms such as ICQ, IAM, Yahoo, and so on. So this is also possible. So not only possible, it is possible, but not just only possible, but additionally it is also possible to communicate with other like internets. Okay. So look at this XMPP technologies: core, jingle, multi-user chat, PubSub, Bosch. Okay. So we'll see the weaknesses. There are different weaknesses as well of XMPP protocol. It does not support QoS, quality of service, and text-based communication, including like with the higher network overheads, and binary data must be first encoded to base 64 before transmission. So these are some of the examples that we can talk about. So binary data has the binary data which is generated must be encoded in the base 64 before it is transmitted. So different applications that use XMPP published subscriber systems, PubSub systems, then singling for voice video file transfer, gaming applications, IoT applications such as smart grid, social networking, and so on. These are different examples or applications of XMPP. So with this, we have come up with other two protocols. We have discussed two other protocols called Xmpp protocol. That is very useful. So we have discussed that the CoAP protocol, that session layer protocol, which is useful for use in the similar kind of platform where REST is required for communication between the client and server. So CoA protocol, and then we have discussed about XMPP protocol, right? So with this, we have completed XMPP, and then we are going to see the next part, that is Amqp. Okay, so we'll continue with this next topic. And the other protocol that we need to know, that is Amqp, that is Advanced Message Queuing Protocol. Okay, we are going to take a very important or interesting protocol which is bit different from like previous protocols that we have been discussing as for. Okay, this protocol is a Amqp protocol, and the full form of this is Advanced Message Queuing Protocol. And this Advanced Message Queuing Protocol basically follows some kind of open standard which is based on ISO. So it follows some basic standards, that is ISO IEC 1964 standard. Okay. So this standard basically helps to define how myths are going to pass from business applications or organization. So in other words, a particular business is composed of different systems and different processes, different business processes. So business can be conceived as a collection of different systems and business processes. So this particular standard helps in communicating between these systems. So connecting between the systems and a business process of a particular business. So binary application layer protocol. So it is a binary application layer protocol. In this application layer, the unit is used for data transfer. In this case is known as frame. So it is a bit different from the concept of a frame in the link layer. So here also some known frame, but it is exactly some frame that is like we talked about the concept called link layer protocols. Okay, look at this picture. You can see that the clients, and in between you have servers. So whenever you're requesting for a video or any file, it received by the server, that is a broker, he'll handle the situations and he'll send to the client again. Okay. Let us understand how this particular protocol works. So we have clients which are producers of different messages. Okay, these are all the producers present in producers are different messages, okay, which have a server, and the other one has, on the other hand, we have again a client which are of consumers. These are producers of clients, and these are clients of consumers. Okay. So we have a server in between, which routers and filters queues for forwarding the message. For queuing and for buffering and forwarding the messages, then we have a consumers of the message. So this server basically acts as a broker in between these two clients. So especially what happens in these clients, for example, different servers or different sensors, they produce different data. Yes or no? Different sensors will produce different data. They produce different messages. So these messages are not to the different routers and filters in this manner, which again can be buffered in a queue and within the intention of forwarding them. Again, in the future and these days, the forwarded data beyond the server are sent to the other types of clients, which are the consumers of these messages. So we have the producers, we have server in between them, and the consumer. Okay, AMQP features, organizations, technologies, time, space. Okay, AMQP can be thought of a collection of different features. As I said, organizations, technologies, a collection of connecting different technologies, connecting different organizations with respect to time and space. Okay. So the main features of AMQP is to connecting organizations, technologies, time and space, which could be distinct from one another. Distinct organizations, distinct technologies, with respect to time, variations in the space, AMQP basically helps in connection. Okay, the features of AMQ is security, reliability, interoperability, routing, queuing, and open standard. Okay, these are all different features of AMQP. So message delivery guarantees. So at most one, at least one, exactly one. These are different messaging formats, okay, which are involved in particular protocol, which are required to have message delivery guarantees. These message delivery guarantees can be of three kinds. That is at most once, that is each message is delivered once or never. At most once. It means each message is delivered once or never. At least once. Each message is um, certain to be delivered, but may do not some multiple times. Okay, at least once it has to be sent to the client, not multiple times. Exactly once. Messaging will always certainly arrive and do so only once. AMQP frame types. There are different, these are all different types of AMQ frame types: open, begin, attach, transfer, flow, disposition, detach, and close. Okay. Each frame type is meant for a purpose. Open is used for connection open. Begin is for session open. Attach is initiate a new link. Transfer is for sending actual messages. Flow is to controls message flow rate. Disposition informs the changes in state of transfer. Detach, terminate the link. End, session close. And close is for connection close. These are different components. Okay. The components are exchange, queue, binding. In the exchange part, it is a broker. Exchanges happen between through a broker, receives messages and routes them to the queue. Queue is a separate queues for separate business purposes. Consumers receive messages from queues. Okay, try to analyze the concept. Okay, so whenever like we want to send a message from one client to the other client, for each business purpose they're going to maintain separate queues so that consumers receive messages from those queues. Okay, binding rules for distributing messages. It means who can access what message, distinction of the message. So exchanges are like direct, fan out, topic, header. The features of AMQP is targeted QoS, Okay. Selectively offering QoS to links. Persistence, delivery of messages to multiple consumers, possibility of ensuring multiple consumption, possibility of preventing multiple consumption, high speed protocol. So these are the different applications that this concept is used. So monitoring and global update sharing, controlling different systems and processes to take each other, to talk each other, allowing servers to respond to immediate requests quickly, and delegate time consuming task for later processing, distributing a message to multiple recipients for consumption, enabling offline clients to fetch data at a later time, including fully asynchronized functionality of systems, increasing reliability and uptime of application deployments. Okay. By this, we have completed the basics of networks. Okay. Basics of networks comes with a lot many topics as we have completed in our 3 videos. So in then my next video, we'll start with this communication protocols concept. Okay. So with this, I'm winding up. Thank you.